Welcome back to Math 6. This is Chapter 3, Section 5, Adding and Subtracting Decimals. We're going to start doing the review it on the side of your note-taking guides. Basically what it's going to do is take us through back a section or back to a different chapter to remind you how to do certain things. So explain how to estimate the sum of two decimals using rounding. So basically, this is from 3-4. How do you explain how to estimate the sum of two decimals using rounding? So first, you would say, actually let's write this in written form. So you could say first round each number to make a certain or to make a whole number. So basically what you're going to do is you're going to have a decimal and you're going to round each number to make a whole number. You could round to the ones, tens, hundreds, digits, whatever you want to round it to. Then you take these nice number and add them. Alright, so, and what this is going to help us deal with is this is how we check for reasonableness. This helps us check for reasonableness, and this is why. If you have numbers like and you want to add that to that's a lot of stuff to add. There's a lot of places you could make some big mistakes. So instead, you should check for reasonableness by taking, let's say it's 20, and 130. So 20 plus 130 gives us a 150. Now, when I go ahead and add this, if for some reason I don't line the decimals up properly and I end up with something like this, if I end up adding them up and it ends up being this right here, I know that 345 and 150, that is not reasonable. And once I know what the reasonable answer should look like, it makes me more confident that I got the correct answer. So this is the purpose of estimating the sum. So the first example here, estimate 75.6 plus 21.3. So they're rounding 75.6 to 76 and 21.3 to, you could just say 21. Because adding this together, 6 and 1 is 7, 97 is a very easy thing for us to add together. So now, when we are adding, you, step 1, line up the decimal points, and 2, add as with whole numbers. So 6 plus 3, 5 plus 1, 7 plus 2, and drop the decimal, so there you go. All right, so the sum of 75.6 and 21.3 is 96.9. Is that reasonable with 97? You should say that makes sense. I should feel confident I got the right answer. All right, here's some more. This time we're going to take 10.756, 6.238, and we're going to get an estimate first. This is about 11 minus 6, so it should be approximately 5. Now when I subtract these, you subtract as with whole numbers. So 6 minus 8, I have to get a extra 1 from there. 16 minus 8, 4 minus 3, 7 minus 2, 10 minus 6. So 4.518. Is that reasonable with 5? You should say yes. All right, let's do some of these on our own. Let's start by estimating. 346, 34.6 is about 35. 53.2 is about 53. So my answer should be approximately 88. If I don't get an answer close to 88, I know I made a mistake. Now let's put them together like you would with a whole number. 6 and 2 is 8, 4 and 3 is 7, that's 8. So how does 87.8 and 88 compare? Are they close? You should say yes, we did this correctly. 24.758, that's approximately 25. You're subtracting about 18. The difference between those numbers is 7. So if my solution is not close to 7, I know I made a mistake. 24.758, 18.315. Subtraction as usual. 6.443. That is that approximately 7? You should say yes. All right, explain in your own words how to find the difference between a whole number and a decimal. Basically, what is there's something called annexing. Annexing zeros. So the first thing you're going to do is you're going to line up. Oh, let me write this out. First, you're going to line up decimals, and then put zeros in. So decimals, first line up decimals, and then put zeros in. So decimals, we'll say end in the same placeholder. And so decimals end at the same placeholder. Basically, you're going to have numbers like 2 minus 1.445, and you line the decimals up and you put in some extra zeros so they end in the same placeholder. So here's our first example. Of course, the first thing we're going to do is estimate so that we can check for reasonableness. So 8 minus 1.74 is about 8 minus 2, which should be approximately 6. So for adding and subtracting, you line up decimal points. And then there's this word annexing zeros, which means you just go ahead and put some zeros in there so that everything lines up in the same placeholder. Because now you can add and subtract like you would with whole numbers. You can't do zeros, you have to carry some borrow. So that's a 7. It's technically a 10, but we're borrowing one, and so we can have a 10 here. 10 minus 4 is 6. 9 minus 7 is 2. 7 minus 1 is 6. So the answer is 6.26. Is it reasonable? You should say yes. All right, let's check our understanding or check your progress. First of all, you need to look at the fact that this is basically 9 minus 3, so my answer should be very close to 6. Then we line up the decimal points, and we annex zeros. Basically, we just add some zeros there. It does not change. Annexing zeros does not change the number. It doesn't change the number. It just gives it a couple more zeros. So, got to do some borrowing. .72 compares to 6. Absolutely. All right. So here's some examples. The table shows the diameters of 3 of the largest food items ever created. So we need to, what is the difference in meters between the world's largest pizza and the largest pancake? So here we are worrying about the largest pizza. Compared to the largest pancake. So let's do some estimating. 37.4 rounds to 37 minus 15, which ends up being 22. Now we line up the decimal points, annex a 0. So 37.4 needs an extra 0 for it to line everything up. So let's carry a 4, or let's borrow from the 4. 10 minus 1 is 9. 3 minus 0 is 3. 2. 22.39. So the difference is 22.39. And when we check for reasonableness, we'll say 22.39 is approximately 22. So you should feel confident that your answer is correct. All right, the local movie theater sells an average of 65.8 tickets on Thursday and an average of 288 tickets on Saturday. How many more tickets are sold on Saturday? So more tickets, how many more? That is a subtraction problem. You're going to do 288.9 and subtract 65.8. Please notice that the decimals are lined up. Please notice we do not need any annex zeros here. But you really need to estimate. So we're going to say this is approximately 290. And we're going to round this to 60. You should really do 66. But if you wanted to do it in your head, 290 plus 65 is probably easier. 0 plus 6 is 6. 9 plus 6 is 15. So, oh, what did I do wrong here? I added. But I told you that this means subtraction. So let me actually write that in there. So now I need to borrow one of the 9's. 10 plus 6, or 10 minus 6, 8 minus 6, 224 more tickets. So 224 more tickets were sold, approximately. Now let's actually work it out. 9 minus 8, 8 minus 5. So the actual number is 223.1, which is approximately 224. You should feel very confident that you did this right. All right, review it. What is an algebraic expression, and how do you evaluate an algebraic expression? An algebraic expression is like an equation. Are like equations. Algebraic expressions are like equations. But without an equal sign. You could also say that they are terms separated by addition or subtraction. So, this is an algebraic expression. We need to do A minus B, and A is 10.75 and B is 4.8. So, we do some estimating. 11 minus 5 should be approximately 6. First thing you do is line up the decimals. Annex a 0. See how this has 2 decimal places, this only has 1. So you had to add a 0. And then subtract as with whole numbers. So 5 minus 0, can't do 7 minus 8, so you have to borrow from the one before. 0 minus 4, can't do that. You have to end up borrowing all the way from the tens. So this 0 becomes a 9. So 17 minus 8, 9 minus 4, 5.95. The value is 5.95. And when you check for reasonableness, you should see that they are very, very close together. Should not cause any issues. All right, last slide. M plus N. So here's M plus N. M just happens to be 40.62 because they tell us that. N just happens to be 29.51 because they tell us. And I need to now estimate. 40 is approximately 41. 29 is approximately 30. So you're looking at approximately 71 as the whole number solution. Now, it's better when you're actually solving this you have to line up the decimals and then perform the addition. 2 plus 1, 6 plus 5, 1 plus 0 plus 9, 70.13. Is that approximately 71? It sure is. All right, so we will work on some of these problems in class, but you should be working on the CYUs at home. So good luck.